The EPA says your tap water is safe to drink. Health agencies have been saying that for decades, but here is what the actual data shows. Safe to drink does not mean safe to cook with, and nobody is talking about this. Chlorine, fluoride, heavy metals, and dissolved minerals are inside every single recipe you make. Your pasta water, your morning oatmeal, the broth you spent 3 hours building, every single one of them is being quietly altered by an ingredient you never consciously chose to add. And the worst part? You have been tasting the difference your whole life. You just blamed the recipe. Studies from the Water Research Foundation show that chlorine compounds alone can degrade heat-sensitive vitamins by up to 40% during cooking. 40%. That is not a rounding error. That is nearly half the nutrition you thought you were getting. Stay with me, because by the end of this video, you are going to understand exactly what is happening inside your pots and pans, and what to do about it today. Let me paint the picture most people are living in right now, because I want you to recognize yourself here. You are doing everything right on paper. You are buying organic vegetables. You are reading ingredient labels. You are avoiding processed food. You are maybe even meal prepping on Sundays. And yet something still feels off. Your homemade soups never taste as rich as a restaurant version. Your vegetables come out slightly mushy or weirdly bland. Your rice has a faint chemical aftertaste you always blamed on the brand. Your morning coffee tastes different when you travel, and you figured it was just the coffee. But it was never the coffee. It was never the recipe. It was the water. Here is the betrayal nobody warns you about. The food industry, the recipe industry, even most nutritionists, they assume you have neutral water. They write recipes for a fantasy kitchen. Your kitchen has chloramines. Your kitchen has calcium deposits. Your kitchen has trace arsenic levels that the EPA considers acceptable, but your taste buds and your gut do not. You followed every rule, and the one variable nobody mentioned was quietly undermining all of it. When people start noticing something is wrong with their cooking results, they go through a very predictable cycle. First, they blame the ingredients. They switch to a more expensive olive oil. They buy a different sea salt. They upgrade their pasta to an Italian imported brand that costs 4 times more. Then they blame the cookware. They spend $200 on a stainless steel pan or a cast iron skillet because they watched a YouTube video that said non-stick is the problem. Then they blame technique. They watch 40 tutorials on how to properly salt pasta water or how to sweat onions correctly. And some of those things help a little, not because they fixed the real problem, but because they added enough other variables to mask it slightly. Then there is the group that goes even deeper. They start filtering nutrition information through multiple sources, trying to figure out why their spinach is losing color during cooking, or why their beans never soften properly even after hours in the pot. They read about hard water. They maybe even buy a water softener for their whole house, which, by the way, introduces a completely different problem by adding sodium to the water supply. The actual root cause stays completely invisible because nobody in the food space is connecting these dots out loud. Here is the chemistry they never taught you in school, and I am going to make it fast and simple. Chlorine, which is in virtually every municipal water supply in the United States, does not just disappear when you boil water. It partially evaporates, yes. But chloramines, which most cities switched to after 2000 because they last longer in pipes, do not evaporate easily at all. A 2019 study published in the journal Environmental Science and Technology found that chloramines persist through standard boiling and actively react with organic compounds in food. What that means for you practically: they bind with the amino acids in your proteins, they disrupt the Maillard reaction, that is the browning process that creates flavor, and they accelerate the breakdown of B vitamins including folate and B12. Then there is hardness. If your water has high calcium and magnesium content, which over 85% of American households do according to the U.S. Geological Survey, those minerals are actively competing with the cell walls of your vegetables. They make the pectin in plant cells tougher. That is why your carrots stay weirdly firm. That is why your beans take forever to soften. That is why your greens lose their bright color faster than they should. And then there is the flavor layer. Dissolved solids, trace metals, and pH levels all directly affect how your taste buds receive food. You are not imagining it. The science has been there. It just was not being told to you. I want to tell you about a test that a food science researcher named Dr. Gary Beauchamp conducted at the Monell Chemical Senses Center in Philadelphia. His team gave trained taste testers identical broths made with water from different municipal sources across 12 American cities. Same ingredients, same cooking time, same temperature. The results were not subtle. Testers could identify distinct flavor profiles, and not in a good way, from waters with chloramine levels that were still within EPA safety guidelines. Within the guidelines. This is the turning point that changes everything. Safe is not the same as neutral, and neutral is what cooking requires. Think about what a professional chef actually does. High-end restaurants in New York, Paris, and Tokyo run their kitchen water through reverse osmosis or multi-stage filtration systems. Not because the tap water is dangerous, because they know that water is an active ingredient, not a passive carrier. They treat it like salt or acid, something to be controlled and calibrated. The moment you understand that water has a flavor profile, has a mineral profile, has a chemical profile, and that all three of those things are interacting with your food before it even hits the plate, you cannot unsee it. This is the turning point. You are not a bad cook. You have been cooking with an uncontrolled variable that nobody told you existed. Now here is what changes when you actually control your water. And I am going to be specific because vague promises are what got us all into this mess with nutrition advice in the first place. When you remove chloramines and reduce dissolved solids in your cooking water, your vegetables hold color significantly longer during blanching. The chlorophyll in your greens stops breaking down as fast because the chemical interference is gone. Your beans and legumes soften in roughly 25 to 30% less cooking time, something that multiple home cooking communities have documented when they switched water sources. Your broths and stocks develop deeper, cleaner flavor because you are tasting the actual ingredients instead of the mineral and chemical noise underneath them. Your pasta has better texture because hard water minerals were interfering with the gluten network formation. This was actually studied and published in the journal Food Chemistry in 2014. And perhaps most importantly for the people watching this who care about nutrition density, your heat-sensitive vitamins survive cooking at higher rates because the oxidizing agents that were degrading them are no longer present. This is not a placebo. This is not a supplement company making a health claim with no data behind it. This is basic food chemistry. The food you were trying to eat correctly. You are finally getting what you paid for. Let me break down the mechanism one more time so it is completely locked in your mind, because understanding the why is what makes the change permanent instead of another tip you forget by Thursday. 3 things in standard tap water are actively working against your cooking. 1. Chloramines. These are chemical disinfectants that react with organic material, your food, and degrade vitamins, alter protein structure, and add off flavors that register as flatness or a faint chemical edge. 2. Hardness minerals, primarily calcium and magnesium at concentrations above 120 milligrams per liter, which is classified as hard water by the USGS. These minerals compete with your food's cell structure, slow down cooking of starches and legumes, and can leave a chalky residue that dulls flavors. 3. pH. Standard municipal water often sits between 7.5 and 8.5 on the pH scale. Slightly alkaline water affects the Maillard reaction, meaning your food browns differently, which directly changes flavor development. Filtered water typically brings pH closer to neutral, around 7.0, which is where most cooking chemistry performs optimally. None of these things will send you to the hospital. That is why the EPA does not flag them. But all 3 of them are silently stealing flavor, texture, and nutrition from every meal you cook. That is the real story. That is the data that changes the way you look at your kitchen. Alright, so what do you actually do starting today? And I want to give you a real spectrum here because not everyone is at the same stage. The first and most accessible step is a quality water filter pitcher. I know that sounds almost too simple after everything we just covered, but this is genuinely where most home cooks should start. A good filter pitcher using activated carbon and ion exchange resin, those are the 2 technologies you want to look for on the label, will remove chloramines, reduce heavy metals including lead and mercury, and lower the dissolved solids that cause hardness. The difference in your cooking is noticeable within the first week. I have linked the one I actually use in the description below. It is the most practical kitchen upgrade for the money I have come across, and it requires 0 installation. You fill it, you wait a few minutes, and your cooking water is fundamentally different. If you want to go deeper, Undersink filters and countertop reverse osmosis systems remove even more, including fluoride and trace pharmaceuticals that pitcher filters cannot fully address. But start with the pitcher. Get the baseline experience of cooking with clean, neutral water before you decide how far down the rabbit hole you want to go. For those of you who want to test your current tap water first, which I genuinely recommend, your city is legally required to publish an annual water quality report called a Consumer Confidence Report. Search your city name plus Consumer Confidence Report and you will find exactly what is in your water right now. Read it. You will not be bored. Here's the thing I want to leave you with. You have been told for years that the reason nutrition advice keeps changing is because science is complicated, and that is partially true. But a lot of the reason your results do not match the advice is simpler than that. You are cooking in an uncontrolled environment, and nobody in the nutrition or recipe space is accounting for the water in your specific zip code. You are not confused because you are not smart enough. You are confused because you were never given the complete picture. The food industry profits from your confusion. The supplement industry profits from nutritional gaps you would not have if your food was cooked correctly in the first place. And the one variable that sits at the foundation of all of it, the water, costs almost nothing to fix. If this changed the way you see your kitchen, subscribe. There is a lot more of this kind of content coming. The stuff that sits underneath the surface of mainstream nutrition advice and actually explains why your results do not match what you were promised. And share this with one person in your life who you know is doing everything right and still wondering why it is not working. They deserve to know this too. Disclaimer. This video is for educational and entertainment purposes only. Nothing constitutes professional advice of any kind.